Hello, this is a continuation of section 4.4. Example 6. Set up and solve the following application. The community college theater department sold three kinds of tickets to its latest play production. The adult tickets sold for $15, the student tickets sold for $10, and the children tickets sold for $8. The theater department was thrilled to have sold 250 tickets and brought in 2,825 in one night. The number of student tickets sold is twice the number of adult tickets sold. How many of each type did the department sell? So I'm going to set up a table here. We're going to have our total price. Then we're going to have our price per ticket. And then we're going to have the number of people. That's what my columns will represent. Then we have adult, student, child, and we also have a total. So the adult tickets were $15, student tickets were 10, and the children tickets were 8, and a total dollar amount for tickets does not make sense here. So I'll just black out that box. Now I do not know how many adults there were, so I'll say X. I do not know how many students there were, so I'll say Y. And I do not know how many children there were, so I'll say Z. But I do know the total number of tickets sold were 250. Well, now the total price is the price per ticket times the number of tickets. So for adults, it would be 15x. For students, it would be 10y. For children, it would be 8z. And then I know the total we sold was $2,825. So I'm hoping right away you see that we get these two equations. X plus y plus z has to equal 250, first of all. Then we get 15x plus 10y plus 8z equals 2,825. So we get two equations from the table. Unfortunately, since we have three variables, we do need three equations. Well, the third equation literally just comes from this sentence that was given in the problem. So the number of student tickets sold, so student was Y, is twice the number of adult tickets sold. So Y equals 2x. Now, whenever you have an equation like this provides you a shortcut to solving these types of equations as well. Whenever you have one equation that is solved, like C is here, I can substitute that into the first two equations to get two new equations. So I'll call these A prime and B prime. So A prime will become x plus 2x plus z equals 250, or otherwise 3x plus z equals 250. And B becomes 15x plus 10 times 2x plus 8z equals 2825, which becomes 35x plus 8z equals 2825. So by substituting C into A and B, I now have two equations with two variables. So I'm going to go through normal elimination methods. When I look at X, I would have to get 3 and 35 to match, which doesn't come easily to me. But when I look at Z, I have 1 and 8. I just need to take 8 prime times negative 8. So that's negative 24x minus 8z equals negative 2,000. And then we get 35x plus 8z equals 2825, and that is just b prime. adding these together, we get 11x equals 825. Divide by 11, divide by 11. We get that x is equal to 75. Now I'm going to take this and plug it into A prime or B prime. I'm going to choose A prime. So we get 3 times 75 plus Z equals 250, which is, what's 3 times 75? 225 plus Z equals 250. Subtract 225, subtract 225. We get Z equals 25. And then also, I'm going to take up my x value and plug it into C, and we get y equals 2 times 75, so y equals 150. So then our answer is there were 75 adult tickets, 150 student tickets, and 25 children tickets. And that's the end of section 4.4.